So Dominique Fober will talk about building Faust with Cmake. So.
Yeah. That's better. Okay. So let's go. Well, my name is Dominique Fober, and I will talk about building Faust with Cmake. I hope everybody has a little knowledge of what Cmake is anyway. I will explain first what is Cmake. Cmake is an open source cross-platform family of tools designed to build, test and package software. Cmake is used to control the software compilation process using simple platform and compiler independent configuration files, and generate native Make files and workspaces that can be used in the compiler environment of your choice. That's what you can read on the Cmake page, web page, where it's located at cmake.org. And so why Cmake? Because it's platform and compiler independent. It generates native Make files and workspaces, and you can use the compiler environment of your choice. And in addition, Cmake is really more and more widely used and supported, and provides a lot of extension to find different packages. For example, LLVM is building system is entirely based on the Cmake. And in the Faust case, it provides really a very interesting flexibility to control what you put in your binaries and what you put in your product. And that's what I want to explain now. So, building the simple way. Actually, what I did, I tried to not to change the simple way to build Faust. So if the simple way was cd Faust make sudo make install, and that's already working the same way. And it works on Linux, Mac OS, it works also on Windows, supporting MSys2. And on output you get the Faust compiler, including not all the backends, but okay, the backends listed here, and the Faust HTTPD static library and the Faust OSC static library. And you can find the binaries, Faust binary int, the folder, a build folder located into a build folder, and the libraries into a lib folder located into the build folder. So actually, when you call make at the top level of the Faust repository, at this level you find a new folder named build, and it calls actually the make file located in the build folder, which is calling Cmake to generate everything and to compile. And in this build folder you find the Cmake project description, a folder named backends that contains various backend setup, and the output folders that I have just mentioned. And actually, when you can call make at the top level, but you can also go into the build folder, call make at this level, which is a little bit different. Actually, from my perspective, the best way, if you don't want, unless you have you don't have any specific requirements, so the best way is to go into the build folder to do what you want to do. And so you can call make at the top level in the build folder, or even call Cmake directly from the build folder. So quick overview of the building steps. In the first step, you select different things where you compile. Here I'm assuming you are already into this build folder. And in the first step, you select where you want to compile, what you want to compile, the backends, the different backends you want to include, and the different libraries you want to include into your project, and the native project you want to use. By default, everything is compiled into a folder named Faust, and if you want to change that, you have various options at make level. For example, you can type make Faust equal any name. You can select different backends, and I will give more details about that. And you have also an option at make level to select different sets of backends, and an option also to select your native project. And so you can select any native project supported by Cmake on your platform. So it depends on your platform, your operating system, and what building tools you have installed on your system. So the backend selection. This, I think, that's quite a new feature in the building process. It was more or less present at the beginning, but not really as flexible as it is now. So, in the first step, you select what backends you want to include into your binaries, and for that you have a set of backends configuration files. These configuration files are Cmake commands that are only used to populate the Cmake cache. And everything is described in the Cmake file header, and you have a list of backends and a list of possible parameter for each backend. So when it's off, the backend is not included in any of the binary output. Compiler, you can embed the backend into the Faust compiler. Static, you embed the backend in the Faust static library. Dynamic, for the dynamic Faust library. ISMJS is for the Faust ISMJS library, etc. And WASP for the Faust WASP library. And in this example, this is the default set of backends included into the project. And with the default set of backend, the FEAR backend is off, the interpreter backend is off, LLVM backend is off too, and the Rust backend is off. The C, C++, Java, JavaScript, and all C++ backends are embedded into the compiler, into the static library, and into the dynamic library. And the ISMJS and WASM backend are included also in all this binary, plus the ISMJS library for ISMJS and the WASM library for WASM. So, and backend selections determines what the content of your binaries. Target selection determines the content of your project, meaning that if you think in terms of makefile, when you type make Toto or make TT, when you select your target, you select the different target of your makefile if you choose a make output. Target selection. By default, the system includes the Faust compiler, the OSC static library, and the HTTP static library into the project. So if you are using a make file, you can type make Faust, make OSC, make HTTP. But you can also include a static library. Faust compiler as a static library, as a dynamic library, OSC dynamic library, HTTP dynamic library, etc. And for all these additional targets, you have different targets in the make file to add a new target. For example, you can type make config static to add the static Faust static library, or make config dynamic, etc. Of course, all these make target are also available directly using Cmake, so that you are not constrained to use make. No, really. Oh. So I'll try to speed up. So, for example, if you are using Windows and you don't want to install MCs, for example, and if you want to use a Visual Studio project, you can directly type Cmake commands, and you have equivalent variables at Cmake level and at make level. So these are various targets. In the make file, you have an all targets that compiles all the targets that you have included into your project. So it depends on what you included into it. iOS lib, it's for iOS. ASMJS lib and WASM lib to compile the corresponding library, and a target help, a classical help target. Okay, I'll just show you the output of help, and it's recommended if you have any doubt, just type make help, and you will get access to all the possibilities of the make file. So, and if you don't remember what you have, okay, at Cmake output, I will quickly type make here. I will do it in build. Okay, so here you can, it start with, it start with Cmake stuff, and Cmake display what is really included into your project, the different backends, the backend setup file that is used, the selected backends on per target, and finally the project targets. So if you look at the Cmake output, have all the information about what will be compiled, included what you put into your binaries. If you don't remember, you can relaunch Cmake and type make Cmake, and you will get the same result. So using Cmake commands quickly, how many times? 2 minutes, 3? Okay, in the build folder you have various Cmake list files. These Cmake list files are the settings for the different projects, and so the main one is at the root of the build folder, and you have specialized Cmake files for EMCCs, to compile WebAssembly or WASM code, and for HTTP and OSC. Quickly, if you have a look at these Cmake files, it starts on close to the top of the file. You should find the various options that you can use to control your build system using Cmake. For example, you can call Cmake the include static equal 1 to include the static library. This is an example. If you want to use directly Cmake. So compiling, this is step 2, and this is quite easy, fast. Type make if you want to use make. You can use Cmake, which is quite convenient if you want to build using command line, even if you use an IDE like Visual Studio or Xcode, for example. And of course, you can directly use your preferred IDE. Oh my God, I think so I will skip this part. I don't have any time more. And anyway, it's really not very interesting. Compiling the LLVM backend is reserved to yes, okay. Measures target and say, okay, well, if there is some remaining time for questions,
yeah. Are there any questions?
Thank you. No questions. So I've been crystal clear.
Some questions from the chat? No? Oh, okay. There is one question.
It's maybe more of a suggestion, but it's great that we have this Cmake system now. I still can't get it to work, so I've got to catch you afterwards. But an idea would be perhaps to host some compiled binaries of, for instance, the libfaust on a CDN or something like that, so that projects that want to link against it can have a version that's built by your server, because it's quite complicated to build on a machine. And I've got several projects which use libfaust, and writing the instructions for people is very, very difficult. So it's not completely related to your talk, I'm sorry, but I think it would be great if the kind of perfect outputs of your various options could be hosted somewhere online for a particular version.
Let me just have a look at the top-level Makefile, and maybe there is already a specific target. It's quite easy to compiler. Okay, if you, for example, at top level, if you type make all, you get the compiler, the static library, and the previously mentioned OSC and HTTP libraries. And so you can. Yes, the libfaust. Yes, the libfaust static library. Yes. Yeah. Actually, I put this system in place, but I don't want to choose any default for backends for output of the make. I think it's more on user request that should be shaped, and so.
But Oliver, even with the new system, you still have problems to compile.
Yes, it's telling me the C++ backend isn't there when it is.
Yes, that's the latest glitch. I noticed that as well.
It's probably just
if you do make world, it doesn't have the C++ backend anymore. So there must have been some changes in the configuration lately.
Yeah, but normally C++ backend is always included into.
I think that some problems arise from the fact that you have a previously configured Cmake, and we need to
Yeah, that's. Yes, probably the most important things to understand is that Cmake is really a state machine. And if you want to make sure about what you put, first you can look at the output of Cmake commands to know about what is included into your binaries and into your project. But if you want really to restart something from scratch, you have just to remove the Faust. Okay, you can type make clean, but make clean won't clean the cache, the Cmake cache. So if you want to clean everything, just remove the Faust folder, the Faust dir folder, or your specific output folder, and you are sure that you restart without side effect. But we can discuss it just.
We have to move on now.
Okay.
Something